Good evening, dear students. Okay, so we were discussing the chapter chemical bonding and molecular structure. Okay, so we have completed some 8 questions in the last class. We have seen the synopsis as well as 8 questions we have solved. Okay, so let us continue with the remaining questions. So let us start with the 9th question. Okay. Peroxide ion has 5 completely filled antibonding molecular orbitals. Second point is diamagnetic. Third point has bond order 1. Fourth point is isoelectronic with neon. Which one of this is correct? So these are the 4 points regarding peroxide ion. Okay. So they have, so out of these 4 points, which one of this is correct? They have asked. A, fourth and third. B, 1, 2 and 4. C, 1, 2 and 3. And D, 1 and 4. Yes. What is peroxide ion? H2O2 is peroxide. Right. So how we are going to explain this about peroxide ion? Hyd okay. So this is your H2O2 is your hydrogen peroxide. Right. So they have asked about peroxide ion. So peroxide ion will be what? O2 minus. Okay. O2 okay, O2 2 minus. So O2 2 minus, okay, so the total number of electrons in each oxygen is 8. Okay, 8 plus 8 is 16 plus 2. O minus means 2 extra electrons. So 16, 17, 18. So 18 electrons. So let us fill up the electronic configuration in molecular orbital. Okay, so we know how to fill up sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Okay, then sigma 2pz square pi 2px pi 2py square. Okay, pi star. Okay, pi star 2px square is equals to pi star 2py square. Okay, so this is the electronic configuration when you are filling up the electrons. Okay, so this is the electronic configuration. So this is about molecular, you are filling up the electrons in the molecular, this is a filling of electrons in molecular orbitals, right? So 18 electrons, each oxygen has 8 electrons. So 2 oxygen, 8 plus 8, 16 plus 2 minus. 2 minus means extra 2 electrons. So 18 electrons. So we have to fill up the 18 electron. Now, when you see the electronic, now let us find out first the bond order. Okay, how to find out the bond order? Number of electrons in antibonding minus bonding upon 2, right? So, so bonding minus antibonding upon 2. So find out how you are going to find out. So number of how many are there in bonding? So 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. 12 minus 1, 2, 3, 4, Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Okay, 10, not 12, 10. So count the number of electrons in the bonding orbitals and then in antibonding. So 2, 4, 5, 6, 7, 8. 8, right? By 2. So how you are finding out the bond order? Number of electrons in bonding minus number of electrons in antibonding orbitals by 2. Okay, so how much it will be? 2 by 2. So this is 1. So the number of unpaired electrons here are how many? 0. Okay, there are no unpaired electrons. Okay, there is no unpaired electron because all are paired. You can see all are 2 electrons, right? So the number of unpaired electrons are how many? 0. So when you don't have an unpaired electron, then it is said to be what? It is said to be diamagnetic, right? It is said to be diamagnetic. So this one point is correct. Okay, then and what is the bond order? What is the bond order? Bond order is 1. This is also correct. Okay, it is isoelectronic with neon. What do you mean by isoelectronic? Isoelectronic means number of electrons. Okay, number of electrons are same as with neon. No. Okay, neon and peroxide ion, they does not have same number of electron. Okay, so this is wrong point and has 5 completely filled antibonding molecular orbital. How many antibonding orbitals are there? 1, 2, 3 and 4. Okay, only 4 antibonding orbitals are there. So this is also wrong. So which are the correct points, students? It is second and third. Okay, so which is the answer? Second and third. Okay, so option number C. Okay, option number C is the answer. Okay, option number C is the answer here. Okay, the points, correct points are second and third. So option number C. Fine. Okay, let us go for the next one. Which one of this is not true for benzene? Which one of this is not true for benzene? A, it forms only one type of monosubstituted product. B, there are 3 carbon-carbon single bonds and 3 carbon-carbon double bonds. C, the heat of hydrogenation of benzene is less than the theoretical value. The bond angle between the carbon-carbon bond is 120. Okay, so these are the these are the points. Okay, and which is not true, you have to tell. Yes, which is not true, students? Try to answer. So when you see this, okay. So when you see your benzene, okay, when you see your benzene, so carbon, how is the structure of benzene? So this is the structure of benzene with alternative double bonds, right? So there are 3 carbon-carbon single bond and 3 carbon-carbon double bond. Okay, so there are 3 carbon-carbon double bond and 3 carbon-carbon double bond, right? So here it forms only one type of substituted product. Okay, it forms only one type of substituted product. Then second one, there are 3 carbon-carbon single bond and 3 carbon-carbon double bond. So this is the second point. Okay, and next is what? The heat of hydrogenation of benzene is less than the theoretical value. The bond angle between the carbon-carbon bond is 120. So here, when you see the resonance, okay, so each resonance, that is your CC bond in benzene ring, okay, and this carbon-carbon single bond, it has a double bond character also, okay, and when you measure the bond length, okay, between these two adjacent atoms, so it is confirmed. So your carbon-carbon single bond and double bond, okay, they have a dual character. Okay, they have a double bond character. Your single bond has a double bond character. Now, when you see the bond length of carbon-carbon single bond, it is 1.54 Armstrong. And when you see the bond length of carbon double bond, it is 1.33 Armstrong. Okay, so here option number B. So this is not true about the benzene. Okay, there are 3 carbon-carbon double bond and 3 carbon-carbon single bond. Okay. So your single bond also has a double bond character. So because of that, it is not true. Next question. When O2 is converted into O2 plus. Okay. When O2 is converted into O2 plus, A, both paramagnetic character and bond order increases. B, bond order decreases. C, paramagnetic character increases. D, paramagnetic character decreases and the bond order increases. So here, when you calculate the number of unpaired electrons, okay, in O2 molecule, okay, so the number of unpaired electrons in O2, O2 is how many? 16, right? So if you put the this, okay, when you calculate the number of electrons, okay, if you write the electrons in the molecular orbital, okay, in the, when you fill it in the electronic configuration, so here the O2, the number of unpaired electrons in O2 will be 2. Okay. And in O2 plus, okay, in O2 plus, the number of unpaired electron is 1. O2 plus means it will be 15. Okay. 15 means again, how much it will be? 1. Okay. It will be 1. So what will happen? So your paramagnetic character will decrease. Okay. When you do the conversion of O2 to O plus. So when you are doing the O2 to O2 plus this conversion, what will happen to paramagnetic character? It will decrease. Okay. It will decrease. Paramagnetic character will decrease because 2 electrons are there. It will be only 1. Okay. So if you calculate the bond order, how to calculate the bond order? We know the formula to calculate bond order. Bond order can be calculated as number of electrons in bonding, number of electrons in antibonding by 2. Okay. So number of electrons in bonding in O2 will be 10 and that in antibonding will be 6. Okay. It will be, how much it will be? 4 by 2, that is 2. So the number of this is 2. A bond order between O2. So the bond which is present in O2 is 2. Okay. And when you calculate the bond order in your O2 plus, okay, O2 plus 15 electrons. So it will be 10 minus 5. So the electrons will be 5. So this will be 10, 5 by 2. So that is 2.5. So the bond order is how much? 2.5. So when you're converting from O2 to O2 plus, so what will happen? The paramagnetic character will, what is happening to the paramagnetic character? The paramagnetic character will decrease. Okay. And what is happening to the bond order? You can see bond order is increasing. So option number D. Okay. For O2, it is 2 and for O2 plus it is 2.5. Okay. So paramagnetic character is decreasing and the bond order is increasing. So option number D is the answer. I hope you are getting it. Yes. Okay. Let us go for the next one. Okay. Next question. Which one of the following contains ionic, covalent and coordinate bonds? A, NaOH, B, NaCl, C, NaCN, that is sodium cyanide, and D, sodium isocyanide. Yes. Which of the following contains ionic, covalent and coordinate bonds? Yes. We know what is ionic, what is covalent, what is coordinate bond. When you see NaOH, okay, when you see NaOH, when you see NaCl and sodium cyanide, okay, NaOH, NaCl, Na plus, Cl minus, right? It is a ionic bond. Then your sodium cyanide also Na plus, Cn minus. So this is also your what? Ionic bond. Na plus OH minus is also a ionic bond. What is ionic bond? Transfer of electron takes place, right? Transfer of electron takes place. So you can see sodium is forming positive, and your oxide Cl minus cyanide, they are forming minus. So there is a transfer of electron. Plus sign means what? They are losing electron. Minus sign means they are accepting electrons, right? So when you see these three, they are containing ionic bond and covalent bond. Okay, covalent bond and ionic bond is present with this. Okay, now but your this what, sodium isocyanate, when you consider your sodium isocyanate, okay, when you write Na plus and your isocyanide, right? So your nitrogen is connected to sodium, right? So what is happening here? So here in this type of, in this, okay, in this, what it contains? It contains ionic, it contains covalent, okay, as well as coordinate bond. You can see, okay, it is a coordinate bond. So they have asked what? Which one of the following contains all the three types of bond? Ionic, covalent, and coordinate. So which it is? It is sodium isocyanate. Other three, what it contains? It contains only ionic and covalent bond. But your sodium isocyanide, it contains what? It contains all the three type of bonds are present. Ionic bond, covalent, and coordinate bond. So this is the option number D is the answer. Okay. Next question. Which of the following is not a characteristics of covalent compound? Which of the following is not a characteristic of a covalent compound? A, low melting point. B, no definite geometry. C, insoluble in polar solvent. D, small difference in electronegativity between the combining atoms. Which of the following is not a characteristic of a covalent compound? Okay. So when you see a covalent compound, so what do you mean by covalent compound? Covalent compounds are those compounds, okay, where mutual sharing of electron takes place. Okay. So in covalent compound, okay, they what are the some of the characteristic? So they are okay. So which is not a characteristic they have asked. Okay. The answer which is not a characteristic is option number B. Okay, so low melting point is one of the characteristic. Insoluble in polar solvent is a characteristic. Small difference in electronegativity between the combining atoms. So these are the characteristics of covalent compound. No definite geometry. No, you cannot say covalent compounds, they have a definite geometry. So option number B is not the not a characteristic of a covalent compound. So no definite geometry. So this is not a characteristic of a covalent compound. So option number B is the correct answer. Next one, intramolecular hydrogen bonding is formed in. Intramolecular hydrogen bonding is formed in A, water, B, salicylaldehyde, C, ammonia, and D, benzophenone. Intramolecular hydrogen bonding is formed in A, water, B, salicylaldehyde, C, ammonia, and D, benzophenone. So what is intramolecular hydrogen bonding? Intramolecular means within the same molecule. Okay, within the same molecule, the bonding is formed. Okay, hydrogen bonding is formed. Water. When you see water, okay, water, it is between the two different molecules. Okay, when you see water molecule, it is between what? It is between two different. This is intermolecular hydrogen bonding. Right. Now, when you see ammonia, NH3, this is also okay. So NH3 is also what? It is also a what? It is also a intermolecular hydrogen bonding. Okay. Benzophenone is also a intermolecular hydrogen bonding. Okay. So this is what? This is the structure of salicylic. So within the same molecule, you can see the hydrogen bonding is formed, right? So option number B. What is the answer? Option number B. So intermolecular hydrogen bonding is formed in salicylic salicylic. Okay. So when you see the salicylic, okay, you can see within the same molecule. Within the same molecule, what is there within the same molecule? Okay. So this is the molecule. You can see within the same molecule, what is present? Salicylic. That is a intramolecular hydrogen bonding is formed. So option number B is the answer. Next question. D2sp3 hybridization of the atomic orbitals gives. D2sp3 hybridization of the atomic orbitals gives A. Square planar structure, B. Triangular structure, C. Tetrahedral structure, and D. Octahedral structure. So D2sp3. D2sp3 means how many orbitals are present? D2 means 2. 6. 6 orbitals, right? So 6 orbitals means what type of hybridization? I'll draw it properly. Just a second. So this is what? This is a octahedral structure. Okay. So this is a octahedral structure. So you can see, yes. So this is the octahedral structure. Okay. Okay. So this is the octahedral structure. So D2sp3 means 6 orbitals are present. 2D, 2D, 1s and 3p orbitals. Together it is 6 orbital. So what type of hybridization is present? It is a D2sp3 hybridization. Okay. D2sp3 which is a octahedral. So you can see 4 ligands will take, okay, 4 corners of the square and up and one below. So this type of geometry, it is called as what? It is called as a octahedral geometry. It is called as what? Octahedral geometry. So option number D, which is the answer? Option number D. Next question. Which of the following is diamagnetic? Which of the following is diamagnetic? Okay. Now, which of the following is a diamagnetic? Diamagnetic means what? No unpaired electron. Okay. Diamagnetic means what? No unpaired electrons. Can anybody tell me which is the diamagnetic among the following? Means all are paired. In diamagnetic, all are paired. Okay. So can you tell which is not a diamagnetic here? So when you see H2 plus means H2 means 2 electron. Okay. H2 plus means -1. So it is 1 electron. Okay. So this is paramagnetic. Okay. So H2 plus is 1. He2 plus. He means 2 electrons. Right. 2 plus 2. will be 4 and plus means you have to subtract 1, so it is 3. So 3 electrons, again it is a paramagnetic because unpaired electrons will be present, right? So this is also wrong. So H2 and this is also wrong. Now O2. O2 means 16 electrons. O2 means 16 electron. So 16 electrons also it is a paramagnetic. It is a paramagnetic. So this is also wrong. So N2. When I write N2, so it will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Okay, then pi 2px2 is equals to pi 2py2 and sigma 2pz2. So how many? So 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 electrons and this is a paramagnetic, it is a diamagnetic. Okay, so the answer is, so which is among the following is a diamagnetic? It is option number D. It is option number D. So which of the following is a diamagnetic? It is option number D. Okay. Let us go for the next one. The number of antibonding electron present in O2 minus molecular ion is. The number of antibonding electrons present in O2 minus molecular ion is. O2 minus means O2 means 16 electrons plus 1 is 17 electrons. Fill up the electrons in the electronic configuration of molecular orbitals. So let us put up sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, then sigma 2pz pi is equals to pi 2py square, then pi star 2px square is equals to pi star 2py. How many electrons? 1. Okay. So 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we have filled up the 17 electron. So the number of electron presenting antibonding are how many? So 2, 4, 5, 6, 7. So how many electrons are present here? 7 electrons, right? And in so your options given are wrong. So answer is 7 electron. Okay. So option given is wrong. So it is 7 electron. And how many electrons are present in bonding? How many electrons are present in bonding? 2, 4, 5, 6, 7, 8, 9, 10. Okay, in bonding, 10 are present and in anti-bonding, 7 are present. So here, none of this. Okay, because options are 8, 6, 5 and 4. Our answer is 7. So options given are wrong. Okay. Next question. Hybridized states of carbon in graphite and diamond are A, sp3, sp3, B, sp3, sp2, C, sp2, sp2 and D, sp2, sp3. Yes. Yes. Hybridized state carbon. Okay. So graphite and diamond, they are the allotropes of carbon. Graphite and diamond, they are the allotropes of carbon. So when you study the graphite and diamond in detail, so there we are going to study something called as hybridization. Hybridization. Okay. So mixing of orbitals. So sp2 is the hybridization of graphite and sp3 is the hybridization of carbon. So here in graphite, your carbon-carbon are carbon-carbon bonds. Okay, they are arranged in sp2 hybridized, and in your diamond, the carbon are arranged in sp3 hybridization. So option number D is the answer. Okay, option number D is the answer. sp2 and sp3. So graphite is sp2 hybridized and diamond is sp3 hybridized. Okay, remember this, don't forget. Next question. The pair of compounds having identical shape for their molecules is. The pair of compounds having identical shape for the molecules is. So the pair which is having identical shape is what? Your Xe XeF2. Okay, so XeF2 is a molecule which is having a linear shape. Okay, and ZnCl2. ZnCl2 also is a molecule which is having a linear shape. So the compound which is having identical pairs, okay, which is having identical shape of their molecules is XeF2 and ZnCl2. Okay, XeF2 and ZnCl2. So it is option number C. Next question. HCl gas is covalent and NaCl is an ionic compound. This is because HCl gas is a covalent and NaCl is an ionic compound. This is because A, sodium is highly electropositive. B, hydrogen is a non-metal. C, HCl is a gas. D, electronegativity difference between hydrogen and chlorine is less than 2.1. So here, HCl is a covalent and NaCl is ionic compound. Because why NaCl is ionic and HCl is covalent? Because of the electronegativity difference. Because of the electronegativity difference. So Cl, okay, in both the case Cl is present, but both are forming different type of compound. One is forming a covalent compound, another is forming a ionic compound. Why? What is the reason? It is due to the electronegativity difference, okay, between the hydrogen and Cl, which is less than 2.1. So option number D is the answer. Option number D is the answer. So HCl gas is covalent and NaCl is ionic compound. Why? Because of the electronegativity difference between the hydrogen and fluorine. Okay. Okay. The hybridization of carbon in diamond, graphite, and ethine is in the order. So what is the hybridization of carbon in diamond? In diamond, it is sp3. In graphite, it is sp2. Okay. And what about ethine? Ethine is what? Like this. This is sp. Okay. So it is what? It is sp. So when you have a, what do you mean by sp3? sp3 means all the carbon atoms are single bond. Okay, all the carbon like this. So this carbon is what? This is sp3 carbon. Why? Because it is joined to other carbons by single bond. Now, what is this hybridization of the carbon? This is sp2. Why? Because it is having double bond. Okay. Now, what is the hybridization of this carbon? It is sp. Okay. So when you have single bond, it is sp3. When you have double bond, it is sp2. When you have triple bond, it is sp. Okay. Fine. So option number B. So in diamond, it is sp3. In graphite, it is sp2. And in ethine, it is sp. So option number B is the answer. Okay. Which one of the following structure of a molecule, which of the following structure of a molecule is expected to have 3 bond pairs and 1 lone pair of electrons? Yes. Which of the following structure of molecule is said to be having 3 bond pairs and 1 lone pair? Okay, so when you have a molecule, suppose I take a molecule, suppose I take ammonia. Okay, so ammonia is having 3 bond pairs. Ammonia is having 3 bond pairs, that is 3 NH bonds, and is having 1 lone pair. And is having what? It is having 1 lone pair. So this structure, okay, this structure is called as a pyramidal structure. This structure is called as what? It is called as the pyramidal structure. So option number D. Okay, so if a molecule is expected to have 3 bond pairs and 1 lone pair, then the type of structure which it is showing, it is a pyramidal structure. Trigonal planar means what? This is a trigonal planar. Okay, triangle, in a triangle like form. Okay, like this, it is a trigonal planar. Now tetrahedral means what? Tetrahedral means like this. Okay, octahedral, this is octahedral, right? So octahedral is this geometry. Understood? So these are the geometries. Okay, these are the geometries, different geometries. So trigonal, planar, tetrahedral, octahedral. So the answer is pyramidal. Okay, the answer is pyramidal. Fine. Okay, next, the intramolecular hydrogen bond is present in phenol, O-nitrophenol, C paranitrophenol, and D paracresol. The intramolecular hydrogen bonding is present in A phenol, B O-nitrophenol, C paranitrophenol, and D paracresol. Intramolecular means again within the same molecule. Okay. Now if I write the structures of the molecules, phenol is, this is phenol. So, okay, within the same molecule, there is no this, so this is wrong. Orthonitrophenol is what? What is the structure of orthonitrophenol? So this is orthonitrophenol. Okay. So within the same, this your or this is form. Okay. So if I write the nitro compound, so N O minus, and this is double, sorry, N double bond O. Okay, and O minus. So this is orthonitrophenol. So in orthonitrophenol, what is formed? Intermolecular hydrogen bonding is formed. Next is, this is a compound, that is paranitrophenol. So the groups are far away, so intermolecular hydrogen bonding is not possible. Then is cresol. Next is cresol, paracresol. So this is also not possible. So the answer is B, orthonitrophenol. Okay, because within the same molecule, hydrogen bonding is formed within the same. Okay, fine. Bond angle in pH4 plus is more than that of pH3. This is because of bond angle in pH4 plus is more than that of pH3. This is because of, what is the reason? What is the reason? If I write the structures of both, okay, pH4 plus and okay. So these are the two structures. This is of pH4 plus and this is of pH3. pH3. Okay. Now both here are sp3 hybridized. Both are what? These are sp3 hybridized. But in pH4, what you can see, all are bonded. Okay, all are bonded orbitals. And in your pH3, there are 3 bond orbitals. Okay, bond pairs, and 1 lone pair is present. Okay, because of the lone pair bond pair repulsion, what is happening? The bond angle is reduced. So bond angle in pH4 plus is more than that of pH3. Why? What is the reason? Because of what? Because of the lone pair bond pair repulsion. Okay. In pH4, you can see all are bond pairs, and in pH3, you can see there are 3 bond pairs and 1 lone pair is present. So because of that, what you can see, lone pair bond pair repulsion is more. Okay. Existed more in pH3. So this is the correct answer. So option number D. Okay. Which of the following is an incorrect statement? Which of the following is an incorrect statement? A. Hydrogen bonding is stronger than dispersion force. B. Sigma bonds are stronger than pi bonds. C. Ionic bonding is non-directional. D. Pi electrons are referred to as mobile electrons. So, which of the following is incorrect statement? Okay. So, your hydrogen bonding is stronger than dispersion force. So this is a correct statement. Sigma bonds are stronger than pi bonds. Yes, sigma bonds, okay, are stronger than pi bonds. Pi bonds are little weaker. Ionic bond is non-direction. This is also correct. Sigma electrons are referred to as mobile electron. No. Okay, pi electrons are referred to as sigma electrons. Okay, so pi electrons, they are localized electrons. They are said to be what? They are said to be localized electron. Okay. And they do not move in the structure of molecule. So option number D. So this is not correct. Okay. This is not correct. Okay. 30 questions. See 30 question. Which of the following possesses net dipole moment? Which of the following possesses net dipole moment? A. SO2, B. BF3, C. BeCl2, and D. CO2. Now, when they ask you about dipole moment, first you need to write the structures. Okay, you need to write the structure of molecules. Okay, SO2, BF3. BF3 is what? BF3 is like this. Okay, so this is BF3. Okay, then carbon dioxide, then BeCl2. Okay, and SO2. Okay, so here, now when you see the structure of this, so which of the possesses net dipole moment? So your BF3, okay, BF3 possesses the net dipole moment. So option number B, option number B, net dipole moment. Okay, so so net dipole moment which is present, it is in BF3. Fine. Okay. So these were some of the questions from chemical bonding and molecular structure. So I have tried to solve more questions. Okay, many questions we have solved on this particular chapter. So from this chapter, what all are important things? So please prepare the questions on MOT, molecular orbital theory, then bond order, then about different bonds, ionic bond, covalent bond. Okay, and then take up the questions on VSEPR theory. Okay, different molecules, different structures. Okay, so and hybridization. Okay, then hydrogen bonding. So these are some of the important concepts from this particular chapter. Okay, any doubts? Yes, any doubts up to your? Fine. So I have tried to cover maximum questions. Okay, maximum questions I have tried to cover from this chapter. Okay, so please study on the important things. So if you have any books, okay, please refer that and try to solve many questions on this. It will be a good practice for you. Okay, so anything you have to ask? Okay then. So I'll end the session here. Okay, so we will meet in the next week. Thank you.